Awesome. Okay, so about myself, my name is Hong. I've been, before coming to Vancouver, I was a tennis coach for 4 years as a part-time gig. I went to Monash University, which is in Melbourne, Australia, and I did a Bachelor of Commerce, specialized in actuarial studies, econometrics, and finance. Currently looking for data science roles, but also, just as importantly, I'm looking for a tennis partner. I haven't picked up my racket in the last 5 months since I've been here, so it's really depressing. Probably the worst time to come to Vancouver for tennis, right? So today we're going to be talking about how to predict matches for the 2020 Australian Open. So this was originally a data science competition that I participated in. That was in 2019. This year I'm trying to see if I can beat my performance. Unfortunately, they're not running the competition again, but I still think that there's a lot to learn here. And feel free to stick your hand up, ask questions. I don't really like talking continuously. I'd like to have interaction and dialogue. So yeah. So the presentation is going to be broken down into 3 main parts. The first one is I'm going to give you, hopefully, some sort of introduction to tennis, get you up to date with some of the lingo and the jargon so you can sort of keep up with what I'm talking about. And also I'll give you a background on the original data science competition that I participated in. And then the middle half, they'll be talking about the data transformation and feature engineering. So when it comes to sports analytics and this sort of application, the methodology that you need to use is, I suppose, somewhat unique. So I think once you understand that, you can apply that to a whole similar class of problems. And the last part, we'll be talking about machine learning, my validation strategy, and also analysis of results and things or food for thought. Okay, I'm just curious, who has actually never watched or played tennis before? Can you stick your hands up for me? Okay, so most of you kind of know what's going on, right? There's a few of you who don't, but it's a racket sport, right? So that's kind of what it looks like. So tennis, the objective is basically to hit the ball in such a way that your opponent makes a mistake. So either they hit the ball into the net or they hit it out, right? And it's one of the most popular individual sports in the world, but it can be played in pairs, and that's the format that they call doubles. And there's 3 main surfaces it's played on. It's clay court, grass, and hard court. I grew up playing clay court. I've never played on grass, and I like hard court because the bounce is very even. We'll need to take that into account when we do our analysis because we're predicting for the Australian Open. That's a hard court tournament, and the playing styles for clay and grass are actually very different, meaning different players are actually dominant on different surfaces. And Rafael Nadal is a very good example of that. Extremely dominant at the Roland Garros, still very dominant at the hard on other tournaments, but not so much. I'm just curious, would you guys actually like to see a quick clip of some tennis? Sure. Yes? Yeah. Okay, awesome. So this is actually from the grand final. Hold on. So the tennis point, so the point is the smallest unit of scoring, right? So that starts off with someone serving. So this is Dominic Thiem playing against Novak Djokovic in the grand final. So it must start, the tennis match must start off with a serve. So there's a lot of strict rules governing that. So he needs to make sure he serves that ball sort of over that net into the opposite service box over here, right? And then so that's where Novak Djokovic is standing, and he's got to make sure he returns that ball into the court. But yeah, I'll just let it play. So that's where the point ends, right? So he made a mistake, the point ends there because he hit the ball into net. There's different ways of making mistakes, such as hitting outside the boundary lines or doing what is known as a double fault on your return. So that means making 2 mistakes in a row. But that's hopefully a visual illustration. It's a very dynamic sport. To me, it's very interesting. It's something I'm passionate about. So in terms of tennis scoring, it's a little bit weird. So they don't just count 1, 2, 3, 4, 5, 6. So the smallest unit of scoring is a point, which is what you just saw then. If you win enough points, you win a game. If you win enough games, you win a set. And depending on the format of the match, if you win enough sets, you win, the match, right? The way they count points is a little bit weird. It starts from 0 all. They call it love, but then they go to 15, then they go to 30, and it's not to 45, it's actually to 40. And then if you win the next point, it's a game, right? Interesting thing about tennis is that you must win 2 points in a row. You must win by at least 2 points to secure the game. So you can have some back and forth with both players being stuck at 40-all deuce. Yes?
But the points increment by at least 5, not 2.
Sorry, what do
You said you must win a game by at least 2 points, but you said it increments by fives here, or 10, or it goes 0, 15, 30, 40.
Yes, so if you win 1 point, so if you both start at 0 all, they call it love all. If you win 1 point, you go to 15.
Right.
If you win 2 points, you go to 30.
So
If
that's
you win
not
3
okay, fine.
That's why I said we need to get this. Yeah, yeah. So the way that they count points goes from love, 15, 30, 40. So that's like 4 points.
Okay, so you must win by at least 2 points,
Yes.
not by 2 in the
numbers,
score.
yeah.
Okay, whatever.
Yeah, I don't understand it either. All right, so when you're at 40 all, right, so that's what they call deuce, you need to win what they call advantage. So you win 1 point, you go to the advantage, and then you win a second point, then you actually win the game. However, like you can have some back and forth, people being stuck on advantage, and then kind of like playing a lot of points out, but not really advancing in the game. Yes?
Sorry, earlier you said that if you make 2 mistakes, you lose a point too. What do you mean by
That's
2
the
mistakes?
serve, right? So like, so you know how in that video just then, right? So the way that they started off a point was like with like an overhead shot, right? So you get 2 chances to get that in. Yeah, so if you stuff up the first one, you got a second shot at doing it. If you stuff up both times, then you lose the point. That's what they call a double fault. Yeah. And there's, interestingly enough, actually differences between the first and the second serve. But I won't really be talking about that today. The professional tour, so that's organized by 2 main organizations. The ATP, Association of Tennis Professionals, organizes the men's tour, the WTA for the women's. Above that sits the International Tennis Federation, but I think they also have their own tour as well. But most, for the men's, they play usually in the ATP, and the women's, they usually play in the WTA. Roger Federer, Rafael Nadal, Novak Djokovic, 3 big names that you've probably heard of when it comes to the men's singles, and Serena Williams as well for the women's singles as well. Grand Slams are the most prestigious tournaments, so these are the big 4 tournaments that happen around the globe. Australian Open, Roland Garros, Wimbledon, and US Open, they happen during the year in that order. The Australian Open and the US Open are played on hard court, the Roland Garros is played on clay, and Wimbledon is played on grass. Interesting fact about the Roland Garros, Rafael Nadal, I think, has a 98% win rate at the Roland Garros, which is incredibly dominant for any single player. So that's why we can't be including clay court matches in our analysis. So the Australian Open, this is held in my hometown, Melbourne, Australia. It's in the middle of January, so the hottest part of the year. And there's a few main divisions for the men's and the women's, so they play both singles and doubles. There's other divisions as well, such as the mixed doubles, and I think wheelchair, and also the junior championships as well. In each division, there are 128 players. For the doubles, it means that there are 64 teams because there's teams of 2. For the 2020 Australian Open, there was a prize pool of 71 million, and I think 4.1 million for both the grand finals for the men's and the women's singles. The match formats are pretty much all the same except for the men's singles. So the women's, they play, all other divisions, they play a best of 3, meaning that you need to be the first to win 2 sets. Right? So it's how many sets that you win out of 3. For the men's, they play a best of 5, so it means that the matches usually go for longer. Okay, so now I'll talk about the Australian Open Datathon. This meetup is actually about like casual competitions. This one's actually not a casual competition, in case you haven't realized. So this is actually the website. So I think it's linked on the meetup page, so you can take a look at it yourself. At the top here, we have some, like the leaderboard. So players are ranked based on their combined log-loss scores. So you'd have to make predictions for both the men's and the women's, and then they would average the log-loss for both of them. So that's sort of the main part of it. So there are, I think, in total, like, sorry, you want to use the microphone?
You said for the men and the women, is it men's singles only? Is it singles and doubles?
Yes, sorry, it's for the singles. Like people don't really care about the doubles, unfortunately. Yeah, so in total, there's probably more than 1,000 people actually registering for the competition, but it turns out like only 10% of them actually submitted predictions. So in total, like only 108 people actually submitted something. So with a combined prize pool of $15,000, it turns out to be a pretty lucrative competition. And that $15,000 is spread amongst the top 15 participants as well. So yes. How did I rank? I ranked at about place 60, so that's me over there, entrant 462. Yeah, so I did sort of okay. That was my first data science competition I ever participated in. I looked at somebody's tutorial, changed like a few lines of code, and like here I am, smack bang in the middle of the leaderboard. That's not too bad. Yeah, in terms of data provided, so they provided, I think, two main sources of data. One is the historical match data and also the historical odds, which I think is given by the bookmaker, Betfair. So Betfair is the organizer of this competition. They're like if the name like doesn't give it away, they're an online gambling company. Yeah, so in terms of data, we have two main sources, the historical match data and also the odds. In terms of analysis, I'll be only focusing on the match level data today. Yeah. Let's see what else we need to close that. Okay, so this is a binary classification task. You're going to be given the names of two players, and you want to predict whether or not player one wins. The metric that they use for this is log loss, which I think is quite appropriate because it's like it's closely related to the log odds ratio. Yeah. Have you guys? I assume that most of you guys have seen this before. Is that right? No? Okay, so, well, it's a binary classification metric. The idea is that you want to make sure that you not only get your predictions correct, but you want your predictions to be as close as possible to the outcome. So, for example, if the outcome is a 1, so a particular player wins, the outcome will be 1, right? So what happens to this part of the term is that it gets cancelled out. 1 minus 1 is 0, so then this disappears. So then you want your probability, right, to be as close as 1 to possible, so that the log of 0 will approach, the log of 1 will approach like towards 0, and then so your penalty will be very small. However, if your outcome is 1 and you're predicting something close like 0.05, for example, you're going to get like a logarithmic fall off, and that's going to sort of drop towards infinity. Okay, so you want to, yep. Did you have a go? Yeah, so essentially you want your probabilities to be as close as to the outcomes as possible, not just getting it past the threshold, so to speak. Yeah.
You referred to something called the log odds?
Ratio, yes.
Yeah, what is that and what's the connection?
Let me try and remember. So when you make a prediction, so when you bet, right, so you have like the odds for one player versus like another player. So the log odds ratio is, well, the logarithmic transformation of the odds ratio. So it's P divided by 1 minus P, right? So that's your predicted probability for someone winning. So then this is just basically taking the log of that. So then you get this formula. And I think the Y and 1 minus Y is to account for both cases of winning and losing. Yeah. Okay, so now let's specifically talk about what we're trying to do here. So this is what the sample submission file kind of looks like, right? So you're going to be given the names of two players, player 1 and player 2, and you're going to predict whether or not player 1 wins. It's going to be a 1 if player 1 wins, 0 if not. And you need to make predictions for all possible combinations of players. So there are 128 players in each division, meaning that for each player you'll have to make 127 predictions against how they would fare against all of their potential competitors. So I think in total there are 128 times 127 predictions, meaning 16,256 predictions in total. However, only a small subset of them will actually be realized. It depends on how the tournament plays out, but you still want to make predictions for all possible cases. So that's why, for example, let's just say Rafael Nadal knocks out Roger Federer, right? It means that Novak Djokovic and Roger Federer don't actually play, just for example. So that's why that value is missing. So then you need to make your own predictions for all of these, but you only really count the matches that actually happen. An interesting thing about this problem is that you also need to generate your own features as well. So in most data science competition, they give you the features for the test set, right? So all you're going off of is just the names of the players, which is a little bit interesting. So you have to do a little bit more work before you can actually generate features and feed it into a model. So any questions about that? Because that might be a little bit abstract or difficult to understand. No? Okay, awesome. Okay, so now in terms of data, probably better to give a visual illustration. So this is the data that was supplied by Betfair. So what we have here is, so we have information about the winner and the loser, their names, the tournament details. Important information are the dates and also the surface. So we want to get rid of all those surfaces which are not played on hard court. And we also have information about the ranks of the players, which turns out to be, unsurprisingly, a very powerful feature for predicting player performance. And also the juicy stuff, which is all the match level information, right? So we get things such as information about the number of games that they won, how well they did in their serve, how many times they got the ball in on the return or whatever, and that's broken down by both winner and loser. So this is the data set provided by Betfair. So I can show you like a quick peek of it. I don't think I can actually give it to you because it's a restricted access from the competition. Yeah. Let's see. What else do I want to mention? Yeah, that's basically that. So now I'm going to give you like a broad overview of what we're trying to do here. So this is like the overall workflow. Initial data cleaning and preparation. So that's pretty easy for the Betfair dataset because everything's really clean. But for the dataset that I'll be using for the 2020 like project or whatever, that's going to be a lot dirtier and we'll need a lot of work to sort of get it usable. And then I want you guys to pay attention to steps 3 and 4. So these are like the two most important steps for this methodology. So once you understand that, you can like go crazy with your feature engineering, go crazy with your machine learning and whatnot. But yeah, those two things, why we need to take, why we can't use the features as is, and also why we need to, and how we should convert from like winners and losers into a machine learning format. So I'll be talking about that a little bit later. And then after that, relatively straightforward, I suppose, just feed all your data into a machine learning model. And then step 6, so this is like more of a practical thing that I'm not going to be talking about, mainly because it's kind of annoying, and I don't think we really have enough time. So, but hopefully you'll have enough information to sort of figure out what you'll need to do. So the last step will be actually to generate features for your submission, then like make your predictions as well. But I won't really be going into that. Okay, so the Betfair data, so that only goes up into, I think, let me see, end of 2018 or 2019, right?
Okay.
Oh, yes.
Yeah, I have a question.
Yeah.
The data, so it's like you have pairs of each of the players for
Yes.
the data.
Yeah.
Okay. So, and then the loss function, why did you use binary cross entropy? Are there other methods you could use? Like, and how does it work with unbalanced data sets? Like, cold start problem if you don't have it in your training set? So
I'm going to explain how we go from winner and loser into like a machine learning friendly format, how we derive our outcomes. And I'm going to force it in such a way that we, by definition, will have balanced classes.
Okay.
Yeah. I think it will make a bit more sense once I get through the other parts of the presentation. But yeah, hold that question. Yeah, so this data set only goes up to the end of 2018. So if we're going to be predicting for the 2020 Australian Open, we'll probably want something a bit more up to date, right? So fortunately for us, I asked the original competition organizers. They pointed me to this package. I think it's actually an R package. Its name is Deuce, and they scrape match level data from a bunch of different sources. One of them being Jeff Sackman's repo. So he's like a big guru guy in like tennis analytics. But essentially, it's of the same format, but it's richer and also a little bit dirtier. So when I mean richer, it has more variables. So in total, we have like 75 different columns for the Deuce data set as compared to the Betfair data, which is only 35. So a lot more interesting things to work with. Yeah. But other than that, pretty much the same format. We have the names of the winner and the loser. We have information about the tournaments. Hold on, where's the information about? Yeah, so information about the tournament, the surface, and also player statistics for both like the winner and the loser as well, which is kind of all this stuff here. Where is it? Yeah, so the W prefix is like the indicator for the winner statistics, and the L prefix is for the losers. And this one goes all the way back to 1968, which is really good, as compared to the Betfair data, which only starts in 2012. So it goes back further in time, meaning we have more data to work with, which is always great. Yeah, another detail thing that we need to work on for this is that we need to create our own submission file and also manually input results after tournament end. It doesn't sound like much work, but I think it took me like 6 to 8 hours just to do the men's. And so that's why I'm only going to be focusing for the men's for my analysis today, but the same method can be applied for the women's. I just couldn't be bothered like manually typing out the data myself. But yeah, that's pretty much it. So this is how I did. So this is the men's score from the 2019 Datathon, and this is my final model this year for the 2020 Australian Open. So I don't have the AUC scores and also the accuracy because I think the model that I used for the 2019 competition was trained on a different data set. So trying to make it compatible with the data that I do have now, yeah, I just couldn't be bothered putting the effort into renaming all the variables and stuff. But yeah, so definite improvement. I'm pretty sure for the AUC score and the accuracy, it'd also be better as well.
And maybe you'll get to this, but do you know what drove that improvement, do you think? What do you think was the big factor?
Yeah, mainly I think like the addition of like better features. That's pretty much the main driver, I think. But they're not exactly comparable as well because they're like 2 different years. So like you'll actually see that there's different like the predictability of a tournament actually changes from like year to year, which is really interesting. Like driven due to like random fluctuations, but yeah. But hopefully that serves as an okay benchmark, and you can compare that to the leaderboard as well. In terms of actual leaderboard performance, I did okay. So like some of the top scorers were actually getting into like below 0.5 for the log loss, which is pretty incredible. But the number 1 scorer is actually one of their Betfair models, which I think is just driven by the market odds. And I think they're like as up to date as possible. So they the predictions are updated like right before the tournament, but I'm not entirely sure on that.
And what does market odds mean? Is there some kind of an exchange?
Yeah, so
trade?
So Betfair actually runs their own betting exchange. So like the forces of demand and supply sort of govern like the odds that I think are being sold or whatever. I'm not really an expert on that.
For loss showing there, are they the sum of the logs or they are the mean of the logs?
The combined?
I mean, for each like man, there will be like hundreds of competitions.
Yeah.
Is that the sum of each competition?
It's the average. Yeah.
Average, okay.
Yeah. So you calculate the log loss for each match and then you just average it across.
So from your description of this Betfair market odds model, it sounds like it's based on a lot of data that's wouldn't otherwise be part of the competition, like this market data?
Yeah, I think so, because you had to submit the predictions before the tournament started. I think these are updated right until before each of the individual matches actually start.
Okay.
So, yeah. One interesting that you'll note, thing to note is that the men's log loss is usually actually a bit lower than compared to the women's. I'm just curious, do you guys have any ideas why that might be the case? Sorry? Well, it means that the women's matches are actually less predictable than compared to the men's. Yeah?
Could there be less data available? Could there be less data available just for the women's section?
That's possibly part of it, but it's reasonably comparable, I think. So the main driver is actually just due to the match formats. So I mentioned that for the men's singles, they play a best-of-5 match, right? But for the women's, they play a best-of-3, meaning that for the women's, they have more opportunities for upsets, right? That's just pure statistics. So that's why the women's log loss will usually be a little bit higher compared to men's. I thought that was really interesting. Yeah. So now onto the data transformation and feature engineering process. Yeah. Okay, so after we got our data, so one of the first things that we'll need to do is to clean it up. Let's see. So I have a function here that does all that. Hopefully you can at least broadly understand what's going on. So one of the things that we'll need to do is actually subset to only hard court service matches. All right, so as I was mentioning before, we don't want to be including clay court and also grass court matches in our aggregations and also our training data. And here I'm also sort of filtering out qualifying matches because they're not really that relevant as well. Yeah, and also passing scores, mainly doing some like text operations and stuff and like regex things, mainly because the deuce data set, hold on. So the scores are kind of inputted in a kind of strange way. So what we need to do, so if you can see the score column over here, so like they're written in like the traditional tennis format, 6-2, 6-2, whatever, or like 7-5, 6-3, 6-1. So we need to be able to extract the game counts from that and get the totals for both the winner and the loser. So that's just like text operations and stuff. Dealing with missing values, that's relatively, I think I didn't do anything particularly complicated. I think I just used like I filled by the column means, if I remember correctly. Yeah, let's see where it's in. Yeah, so I think I just filled by the column means, and for players with missing rank, I just filled it with 500. Also doing some light feature engineering to reconstruct data. So that's what all this is doing. So one of the disadvantages about the Deuce data set is that it doesn't explicitly contain information about returner performance, but you can sort of infer that because you know what the server is doing, right? So whereas the Betfair data lays it out both explicitly, the Deuce only has explicitly the information on the server, but you can sort of impute it based on their performance. So that's what we're doing there. And then just cutting out some variables, which are just, these are the ones that I'm just dropping, mainly because they're just filled with too many missing variables, missing observations, so I couldn't be bothered like trying to incorporate them. So that's, I think, to do with the tiebreak information, mainly because not all matches actually have tiebreaks. It just really depends on how the,
Yeah, did you open up the Deuce package? It's R, isn't it? It's an open source.
Yes.
Is it not is it stripping another link? Isn't that what it's doing?
Yes, that's what it does.
Okay. Did you? Okay.
No, so I'm not interacting with it through here. I opened it in R, and then downloaded the data file as like CSV, and then have like sort of uploaded it here.
Oh, okay.
Yeah. Okay. Yeah. So now I'm going to be talking about the data transformation process. So these two slides are actually probably the most important slides of like my presentation. If you understand these two things, you can apply it to like a whole bunch of different sports with similar data forms. Technically, the feature engineering should actually occur before you do the aggregations, but I'm going to talk about these first because I think it makes more sense. But if you're getting confused, please stop me and just ask questions. So now, I think responding to your question, so we have data in the form of winner and loser statistics, right? So we have the names of the winner and loser, but we want to convert it into player one, player two, player one wins. All right, so what I'm going to do here is to actually sort of split each match into two observations, right? So the two observations are kind of just flipped or reversed scenarios. So for scenario one, we're going to allocate the winner to player one, and for scenario two, we're going to allocate the loser to player one. The reason why we need to do this is to induce variability in the target, right? So if you only allocate the winner to player one and only allocate the loser to player two, your outcome is always going to be one, right? So you can't do machine learning with that. If you feed that into like any sort of algorithm, it's just going to break. You're not going to do anything meaningful. So you have to have both cases involved. Right? So then you arrange the features accordingly. So notice how I'm swapping the features for Djokovic and Federer. So 19 and 13 and 13 and 19. Okay. Any questions about that? Yeah. All right, so that's how we wrangle the target and how we convert from winner and loser to player one, player two, player one wins. And now we need to do a rolling average of inputs, right? So this is not actually the feature that I use in my model, but I'm just using this as an example. So the problem with the data in this current form is that the number of games won in a particular match, that sort of information isn't available until the match actually finishes, right? So if you try and use that for prediction, you're going to get 100% accuracy because the player who wins more games than the other will obviously win. So what you need to do instead is to actually look at each player's past performance. So instead of using the number of games that they won in this particular match, you use the number of games that they won in previous matches and take like an average, right? So that's what we're doing here. So instead of Novak Djokovic having 19 games won in his current match as a feature, we're going to look at his previous 3 matches. So he played Denis Shapovalov, Daniil Medvedev, Rafael Nadal, and he won 17, 17, and 13 games in those 3 matches. Then we average those and then use that as a feature for this current match. And you do the same thing for Roger Federer. I've left that as a question mark because I couldn't be bothered putting another table in. Yeah. And then, yeah, you can do this for as many matches as you want. 3 is probably not enough. I chose to do I think between 21 was I think what I found to be the optimum. But that's like a hyperparameter you can potentially play around with. But yeah. Yes?
I have a few curious questions. One, do you have any intuition as to why 21 is kind of a reasonable number?
I have no idea.
Yeah.
It's just like, well, it's small enough so that you're getting up-to-date information, but it's large enough that it's not too noisy. So it's just like the balance between like having more up-to-date information and also a more consistent estimator, I suppose. Yeah.
And how many matches does sort of one individual play in, say, a year?
Oh, that's a good question. Probably about 50 to 100, I'm guessing. That's a ballpark number. Yeah, so in a particular tournament, they could probably play like 5 or 6. Yeah. Yeah, something like that. So it will usually be about like the last 2 or 3 months worth of matches. But yeah.
And what sort of statistics did you roll up in this way?
All of my features that I wanted to use. The only ones that I didn't take a rolling average of were player rank and also player elo. But everything else, so like which are some of the other features I'll explain, and pretty much everything else I did like a rolling average for them. Yeah.
And did you ever consider other aggregations than average, like max or min or something?
No, I didn't. Yeah. That's like, yeah. I don't know. Like
I don't know why, but yeah.
I don't think max or min would work particularly well. I do want to do like a exponentially weighted moving average. I think that would probably work better, but I never got around to implementing it. Yeah, because you want to weight the more recent matches like a bit more heavily, right? Yeah.
And then last question that might be the most complicated. So like you've set this up now, so rather than using the data from this match to predict it, because that would be silly, we know the outcome at that point, use the data that we knew before that match started. But for the tournament, I think you're trying to make predictions before the tournament starts.
Yes.
And so now by the time a player is playing their second match, you don't know what happened in their last match. That must be difficult. Yeah.
So for a particular, so when it comes to the actual tournament, we're not going to be using matches in that tournament to predict future future rounds, if that makes sense. So, for example, for like Djokovic, right? So he plays in the very first round, round 1. So when he moves to round 2, we're not going to be using the information from round 1 to update our predictions. So the predictions are actually going to be constant in a sense, regardless of what round they take place. Does that answer your question? And yeah, the problem is that the data that we have is actually 2 months out of date, so it only goes up to like the end of November, so it's kind of unfortunate. But it's still better than the Betfair data, so yeah.
Is it on? Yes. I am just curious, so you played around with this to get to that number of 21.
Yeah.
Did you experiment with using the entire history for the players?
Sorry, what do you mean by that?
Like all of the matches over their entire history of play?
No, I didn't, because that would take like forever to calculate. Yeah.
Okay.
Because like even with just 21 matches, like it takes like a few minutes to actually churn through, just only for the Australian Open, US Open tournaments. So yeah. But a separate question to ask is like how far in the past do we want to be training our model?
Right.
Yes.
So my thought was that you want to take past what's happened in the past to predict what's in the future.
Yeah.
So can we take, it also makes sense that you want to use recent history, but can you do a combination of like what happened in the last 20 matches and what's their overall like win rate?
Yeah, that would, I suppose, involve like a more complicated time series interaction. But yeah, that was something I've been thinking about, but never got around to actually looking in depth to.
Okay, just curious. Thank you.
Oh, hold on. I think he had the microphone first.
Oh, okay. Yeah, so what you essentially did was to convert a time series problem into a classification problem. So that's why you don't need to so you've added all the lags
well, it's a time series classification problem, I suppose.
Okay.
Like we still have to be careful when we do our validation, I think.
Okay.
I have not actually experimented with that though. I just assume that we shouldn't be doing like cross-validation with our data.
Okay.
Yeah.
About the match that you're predicting for the last row.
Yeah.
When you're taking a rolling average, why didn't you take the rolling average of those two agents in consideration? So I'm guessing that...
Sorry, say that again?
So for, let's say, player 1 and player 2, in this case, Novak and Roger, they must have played games way before 30th January 2020, right?
Yeah.
So why not take the average of those wins who won in those matches to predict the outcome of this match? Why take the average of Novak playing with Dennis, Daniel, and Rafael?
So you mean like specific player to player?
Yeah. So that would take away the omitted variable bias about the skill sets involved, because they both will be improving their trainings, right, to beat each other.
Yeah.
After each match. Yeah. But if you're taking into account Dennis, Daniel, and Rafael, they both are not equal to Roger in any way, right? Yeah. So that would, you see what I mean? Like you would avoid that error.
Yeah.
So why not do that?
That's a good question. Like mainly because it was something I was thinking about, but I never got around to doing. Like a lot of there's like a to-do list of like a million things. Like there's like, but yeah. I think that's definitely a good idea. A few shortfalls with that is what happens with like less experienced players and like who haven't really played each other, especially like in the lower rankings. Whereas like for Novak and Federer, right, they've come across each other like multiple times in their career. So that it works well for the really high level players. But even then, those matches are only they're across like 2 decades worth of like career tennis, right? So that's like going back a long time. So I suppose there's some pitfalls of that approach, but that's definitely a very interesting idea.
And then one last thing I wanted to ask, because it kind of came up, is to what extent or how fast is the game of tennis changing? You know, thinking about how much history to use and stuff. I think probably there haven't been any rule changes, maybe other than the video review stuff. But otherwise, do you think that the game is evolving rapidly?
That's a very subjective question. I think there is probably a way to answer that a bit more objectively, but I would say that it's not that much. I'm only training on data between 2000 to like 2019, so that would be considered the modern era of tennis, which I think sort of counts when like Roger Federer entered the stage, right? So yeah, I'm kind of using that as like the marker for that. But yeah, that's also an interesting question because we don't want to be going too far in the past to train our model.
Excuse me. I had a question that just as you said, like Rafael Nadal has a good record on clay. So if we are going to consider all the previous history or maybe some of the previous history, so it's going to conclude all the Grand Slams. So is it going to be fair enough to consider the previous history to predict the data for one particular Grand Slam? Because like in case of Rafael Nadal, if he's good on clay, there has to be some variables that are going to maybe be in his favor. So is it going to be fair enough to consider the previous history in order to predict the future outcomes? That's what my question is.
Are you talking about this like player-specific head-to-head matchups?
Yeah.
Using that as like past information?
Yeah.
And your problem, you're saying that if they're playing on different surfaces, that's quite problematic.
Exactly.
Yeah. Well, I'm not doing that. So, but I think that's an important thing to understand. So, like Rafael Nadal, I think I mentioned at the start, is incredibly dominant on clay courts. He's actually got a special award just for his dominance in the Roland Garros. He won 10 titles at the French Open, so they gave him the La Decima, which is like, congrats, you're too good at this.
Yeah, because that's what my question is. Yeah. If he's being dominant on one particular surface, so if he's being dominant on one particular surface, there has to be some variable that is playing in his favor on that particular surface. So if you are going to consider the results of that matches and probably consider that history, so it's going to be a bit biased.
Oh, okay, yeah.
So is that fair? That's what exactly my question
So I'm only doing the aggregations over hard court matches. So like I've already filtered out the grass and the
okay, so basically you have just categorized into different surfaces?
Yes.
Oh.
Yeah.
So a popular metric for like football and baseball is like point differentials. So I notice here that there's game differentials like 17 to 13. Did you account for how badly somebody wins or loses? And then part two of that is, does it does that influence based off of how many games total they play? For example, in row 1 you have, or row 2, excuse me, is 17 to 12, so that's a +5 game differential. And in row 3, it's also a +5 game differential, but the amount of games played is 29 versus 21. And so does that mean that row 3 is a more dominant performance, or like, can you
That's
go into
actually
that?
on my next slide, so I'll get to that. So a very awesome segue. So now we're going to be talking about feature engineering techniques. So so this data right now can still be used for machine learning, but we're going to polish some things up. So one of the things that we're going to do is convert the raw counts into ratios. So the problem with like tennis is that the different matches are not comparable. So particularly for a 3-set match and a 5-set match, the total amount of games played isn't comparable. So if you're using the raw counts, you're going to get some somewhat conflicting messages. So what you do instead is you calculate like a game-win ratio, right? So you calculate how many games they played in total and use that as like the denominator, and then on the numerator you would have how many games they actually won. So that sort of, I think that answers your question, right? Yeah. So like if you win 12 games in a 3-set match, that's a lot more impressive than winning 12 games in a 5-set match, right? So that's sort of what it's accounting for. So that's one of the main techniques. So I'll be using that for like the points, the point differentials as well. So instead of like a number of points won, we have like a point win ratio, and also for like service and return, etc. Yeah, and then one thing we can do is actually to weight features by the opponent's rank. So a game-win ratio, let's just say like 0.8, right? So if you're getting a 0.8 game-win ratio against like the rank 1,000 player in the world, that's not that impressive. If you can get a 0.8 game-win ratio against the rank 1 player, that's a lot more impressive. So that's one thing that you can sort of do. So I think I ended up incorporating a weighted game-win ratio and also a weighted point-win ratio as well. Yes, log transformation of player rank. So that's actually pretty useful as well. So I think I have some visualizations of that. That's pretty cool. So the scatter plots, when I plot player 1 wins, which is the outcome, and also against the rank difference, that's not particularly informative, but if you actually look at the correlations, it's about negative 0.2, right? So the greater the disparity, the greater the likelihood of someone winning. However, if we look at the log transform rank difference, so obviously the scatter plot is basically still useless, right? But the correlation actually increases by about 0.1. So I thought that was interesting. So it sort of linearizes the relationship. And here's another visualization that sort of illustrates that. I'm not sure if this is the right way to do things, but I made, so these are actually the predicted probabilities on the y-axis. This one's for the, just for the rank difference, and this one is for the logarithmic transformation of the rank difference, right? So as you can see, like there seems to be a more linear relationship, or at least a slightly more obvious relationship compared to just the non-transform rank difference. But yeah, that's based on the predicted probabilities with that as a feature. So I'm not sure if that's the best way to illustrate it, but I thought that was interesting. Yes. Okay, so that's some of the main techniques. And yes, and we'll also be doing like taking a difference between features. Do you want to pass the microphone to him at the back?
I'm pretty loud, so you can probably hear me.
Okay, but we want to... Yeah.
The camera is there.
Thank you. So I was just curious, the rank, wouldn't it essentially be impacted by all the different court types that they play on? So did you use a rank that was purely based on the hard court, or was this including all the different types?
No, it's including all. Yeah.
Okay.
So that's, I suppose, one of the downsides of the rank. So this is just obtained by the rankings, I think the official rankings, which is based on how many points that they won, which is aggregated across all tournaments. Yeah. So I think it would be a good idea to have like a ranking system based, like separated by court, but I don't think we have that. Yeah.
Do you know how
correlated the results from like clay court versus hard court versus grass would be? Like someone who's very dominant on grass.
Is the microphone working?
Is it not working? Oh. This is on? No. On?
Is that out of battery?
No, I'm probably just doing this wrong.
What's the other mic?
Okay. Maybe you yell out your question. I'll try and repeat it. Okay.
Or can you hear me okay? I can speak with pretty loud.
Oh, well, there's a microphone.
Yeah? Okay. I was wondering like how correlated the results from the various courts would be. Like, I assume a player who's dominant on clay is still likely to be dominant on grass or hard court. I mean, obviously not to the same extent.
Yeah.
But there's got to be some sort of significant correlation between performances. But I was wondering if you had any idea like what those would be. And the rank in particular would have a connection to those correlations. But does that make sense?
Yeah, no, I understand your question. I'm pretty sure like there's obviously a correlation between like different surfaces. It's like if you're going to be like really, if you're a professional player on one court, you're still going to stomp like all non-professionals on all other surfaces. It doesn't really matter. But yeah, when talking about professional versus professional, people of a similar skill set, you do see some like differences. I think maybe don't quote me on this, but I think Roger Federer hasn't played in the Roland Garros in like recent times because of Rafael Nadal, right? And like Nadal is, hold on, actually, maybe I'll show you some interesting statistics at the end. But yeah, I think Nadal's match win percentage is like about 80 to 85% on like the at Wimbledon, the US, and the Australian Open. But whereas, as I mentioned, for the Roland Garros, it's like 98%. So while it would be useful to have more training data, right? So if we can incorporate matches on different surfaces, it would like either double or quadruple our training size, which would be really good. But I think that it just sort of taints our learning process. So I think it's probably not a good idea, and I'll talk a bit about that later as well. Some evidence for that.
I'm not quite familiar with tennis, but it seems like the court itself seems to be like much more important than weather, time of the day, location, or all of those things. At least like you are making your separation based on that.
Yeah.
But aren't all of those other factors somehow as important or somewhat important for you? And are you incorporating any of them?
No, we're not. There's a few reasons for that. One is that it's not included in the data set, and even if it was, we can't use that to make predictions into the future, well, at least not reliably. If you're using weather, for example, we don't know how the weather is going to pan out on the tournament itself, which we're predicting into, right? Like, for example, there might be, the tournament might get pushed back a day, so then that shifts your predictions, or one day is particularly hot, for example. So that's something that we can't really incorporate. And while I do think it does affect player performance, I think it sort of affects both players simultaneously, so it sort of cancels out mostly. Yeah, that's my intuition, but I'm sure people will have other opinions as well. Yes, I think we're running out of time, I think. So I'm only...
we can run up to 8, basically.
Okay, we can run up to 8, awesome. I better get moving then. Here's some other features that I came up with. So I'm not going to be talking about that one. Oh, actually, I'll talk about it briefly. So this is just calculate like an average of previous wins, and then you weight it by your opponent's rank. So if you're winning against high-ranked opponents, that's good. If you're winning against low-ranked opponents, that's not too bad, but it's not as good, right? So that's what we're doing there. So we're taking like the exponent of the negative opponent's rank scaled by some factor. So now this one's, I think, interesting. So the calculation for this is really simple. So it's just the difference between a player's game win ratio and the point win ratio, and it's trying to measure a player's mental strength. So as I mentioned before, the number of points played can be basically without limits. But in terms of the number of games played, that's still fixed and finite. So if a player is able to consistently win those important points and pull through in those events, then that is like a measure of sort of mental fortitude, right? You'll hear professional players at the very highest level. They'll always say tennis is 80 to 90% mental strength. Sure, it's one of the most physically demanding sports out there, but when it comes to tennis, it's mental toughness plays into it as a much bigger factor. So that's what we're trying to measure here. So on those important points, can you pull through, focus, and not choke? That's what the clutch factors are supposed to measure. I have some interesting visualizations for that as well. Yes?
For the clutch factor, don't you think that the tied number of tied games, I think tiebreakers, that you admitted before, wouldn't that affect the clutch factor? Because during the ties, that's where the clutch comes in, right?
Yeah, I guess so. But they don't. Well, I feel like I deleted those variables mainly because there were too many missing values. I think the tiebreak does come into play a few times, but I felt it wasn't worth the effort. But now that I think about it, it might have been. Yeah, that's interesting. Yeah, maybe I'll need to look into that. So this is an interesting graph. Hold on, where is it? So these are the differences. So these are the player point win ratios and the game win ratios for three of the best players here. So we have the top one, Roger Federer, the middle one, Rafael Nadal, and the bottom one, Novak Djokovic. So as you can see, the game win ratio is slightly skewed towards that right tail compared to their point win ratio, right? So you could say that the point win ratio measures a player's like overall skill, right? How consistently can they just win a particular rally? So that measures like their strokes and also just their overall coordination. However, the game win ratio comes into play a bit more on those important points, right? So that's where it switches into more of a mental game, right? So we got to really focus. And so top players can really pull through on those like really important moments. And if you compare that to a rather mediocre player, for example, let's pick on Bernard Tomic, because he's apparently one of the laziest players on the tour. So you can see that he's got game win ratio sort of skewed to on the right and also on the left. So that's kind of illustrating the difference between the champion mindset and just like someone who's just decent at tennis but doesn't really care. So that's that. And then player elo. So this one is actually the most powerful feature at least I found. So I'm sure you guys have heard of this before. It's originally used for chess rating systems. I think if you play League of Legends or Dota, you'll probably come across this as well. It's an iterative ranking system, the idea being that if you beat an opponent then if you win a match, your ranking goes up. If you lose a match, your ranking goes down, and the magnitude by which it goes up is dependent on the difference in scores, right? So if you, as an underdog, you win like a match against a much higher ranked opponent, then the elo boost that you get will actually be much larger than defeating someone who's like lower ranked than you. So that's that. There's a formula to calculate this, but I'm not going to really go into detail about that. Hey, now on to the fun stuff. So the algorithm that I used for this was XGBoost. So I don't want to assume. Has anybody not heard of XGBoost before? Yes, okay, so XGBoost, there's actually, XGBoost, it's what they call a gradient boosting implementation. So gradient boosting is a technique where you have a bunch of like weak models, each one sort of sequentially learning from the previous one's mistakes. And so at the end of it, you get something which is very powerful. I think most of the time when people do gradient boosting, they use what is called a decision tree or a decision stump as like the base learner. So then you have a whole bunch of them, and each tree that you grow is related to the number of boosting rounds. And in terms of hyperparameters, I found that the default settings actually worked like the best for this particular setting, which is really interesting. And I also used 20 rounds for early stopping. So now in terms of validation strategy, we are only going to train on the Australian Open matches. So we'll accumulate or aggregate statistics from like the previous hard court matches, like in like January, November, or December, or however many it goes back. But the actual observations we're going to use are the outcomes from the Australian Open only. And forward chaining, so that's the validation strategy that we're going to be doing. So essentially you break up the data into like sequential time chunks, and then you iteratively train on like a small time chunk, and then you predict into the future. Then you add that next year into your training set, and then you predict one step into the future. So for example, if I start with the year 2000, right? So I'm training my model in the year 2000, then I predict out of sample into 2001. Then the next fold, 2001 gets added to my training sample, predicting on 2001, training on 2000, 2001, and then predicting on 2002. And you basically do that until you exhaust your data set. And then I use the average of test scores to tune my model and also to pick features. And I added an extra layer on top of that. So I use a validation set for the early stopping, and then I predicted 1 year into the future as a truer measure of out-of-sample performance. So, for example, if you're training on the year 2000, use 2001 for early stopping, so to check whether or not your model's overfitting, and then you predict on 2002 as your true out-of-sample performance. Yes. Yeah.
And did you use whole years? I mean, did you do sort of 19 folds or something, or did you do...
Yes, I grouped it by years. Yeah. Yes. Does he have a microphone? Yes.
So I'm wondering how that strategy of those folds helps you. I mean, if the first fold that you're just like taking a few years and looking at the next year doesn't work so well, but the last one is working phenomenally, does the fact that like the first one is not working well, or the first or second year are not working well, how would that affect you in any way?
Oh, that's a good question. Well, you would expect fluctuations from year to year, and I think there is a valid concern that perhaps earlier years are not reflective of past year's performance, but I'm just assuming, I suppose, that the out-of-sample performance in earlier years is close enough to out-of-sample performance in later years. But that's just an assumption, and I probably should use data to back that up. Yeah. Okay, now a question. Should we be including the US Open as a training example? So intuition says, well, yes, mainly because, well, it's a hardcore tournament, it's a Grand Slam. It's played in the same way, the 5-set match. So it's pretty comparable, right? Now, we use a trick called adversarial validation. So this one I discovered from the fraud detection challenge, and I thought it was really interesting. So essentially, instead of predicting on who's going to win, so you include the US and Australian Open tournaments, and then you have a separate outcome now, so an indicator function as to whether or not a particular match came from the Australian Open or the US Open. So if you can accurately distinguish between the US and Australian Open based on the feature sets, then you probably don't want to be including both if you're only predicting on the Australian Open. So that... do you want to pass the microphone?
What's the procedure to figure out the adversarial validation?
Yeah, so that's what I'm going to go through right now. So,
okay, that's good.
Where is it? Adversarial validation. Yeah, so I'm basically taking the data set, right? And then I'm adding a target. So this is a separate target, the indicator function, which is just 1 if the match is from the Australian Open, 0 if it's from the US Open, right? So if your machine learning model or any other classification algorithm can reliably distinguish between the two, then you probably don't want to be including both in your model, right? Because we sort of assume that from a statistical point of view that they're coming from the same population, right? So if that assumption breaks down, then, or if you can disprove that assumption or provide evidence against that, then you probably don't want to be including both if you're only predicting for the Australian Open. Yeah, does that make sense to everybody?
I don't understand the validation part. So what are you validating there, actually?
I don't know why it's called adversarial validation. That's just the name. It's just something I came across recently, I suppose. Yeah, so
I would think that if you have where a match was played as one of the features, then your system would learn how to deal with the fact that there were two different matches in two different places.
Okay, that's an interesting idea. As in have like an indicator function as like a feature? Is that what you're suggesting?
Yes, have it be a feature.
Okay. Yeah. But then it doesn't really matter because we're only predicting for the Australian Open anyway, right?
Well, imagine you had a feature of something like is injured.
Yeah.
Then and that was a feature, then it would tell you, well, whether it was, you would assume that they would usually win when they were not injured. So you could say, well, I'm going to just toss out all of my is injured because, and only use the not injured because it doesn't make sense to include it is injured, because I could do an adversarial validation and I'd clearly be able to tell whether it was injured, whether the person was injured or not. But there still might be useful information in there about how good players are, because the injury might, I mean, if you're injured in your non-playing hand, then maybe that doesn't matter. I'm sorry, I don't think I'm making good sense, but there is information in the matches that are played on the U.S. Open. The fact that you can distinguish it does not necessarily invalidate that information if you keep the location of the match as a feature.
Yeah, I guess so. I think it's a little bit different for the injury example, because players can still get injured during the match, whereas we know that we're only predicting for the Australian Open. Yeah.
Yeah, that's why I realized I was not making a good argument. Does anyone else want to help?
But I haven't actually explored that, so that might be worth looking into.
I want to clarify that you're talking about include the U.S. Open into the features or into the say logs?
Into the rows.
Into the logs.
Yeah.
Okay. Okay.
Because we're only training on Australian Open, we're wondering if we should include US Open data as well.
You include that in the feature, right?
No.
No.
It's just another observation, if that makes sense. So increasing the number of rows, not the number of columns.
But I was suggesting also increase the number of columns, so that you have a column that says
indicator.
Where is it played?
Yeah.
So I just remember this technique looks like one in Andrew Delman's paper, inputting missing data also. But I think in that case, you need another validation after, like you have an indicator function as a label, and you're using your model to predict those labels.
Yes.
And then you set a holdout set to check if your model was able to determine the location.
Yes.
So this is 2 layers, not 1 layer alone. So
yes. So you do have a train test split. So that's the test split is used for. I've set the test data as like the watch set. So that's what the scores are you're seeing over there. So the metric I use for this is AUC. So if they're statistically indistinguishable, then it should be close to 0.5. But we're getting like ridiculously high numbers. I think that might be a little bit suspicious, but I need to double check that. We're getting like scores like close to 0.9. Which is surprisingly a lot more predictable than the actual outcome we want to predict, which is kind of sad.
I'll jump in to say that, so I think throwing the data out, I think this is very clever, by the way, so it's a good piece of analysis. Throwing the data out is an option, making it a feature is an option, actually keeping it in and not making it a feature is an option, and so often in ML, we just don't really know, and so we run the experiments and find out if we have time, basically. And the one that had the higher score is the one we decide is the best choice.
Yeah. I will place another piece of evidence on the table, which is, so this is the the test and validation scores for the Australian Open only data, right? So as you can see that they're moving really closely in sync, meaning that our validation strategy is probably working. You can see another example where with a different model, which is potentially overfitting, they're not moving in sync as well. I'm not sure what the correct interpretation is, but I just thought that was interesting. And you see it like a really big problem when you have the US Open, right? So I don't know what happened in 2004, but yeah. So as you can see, like there is some difference, so potentially suggesting that maybe not such a good idea to include the US Open.
So I would actually make the argument that this is valuable data because I would expect that in earlier years, you're training on less information. You expect there to be more of a difference between those two lines, but they do get really close as we come closer, as we come to 2018. So the other two did that as well. It tends to be worse in the beginning because we have less information to train on. And then hopefully our lines converge as we get closer to where we want to predict to. So this tells me use that. But I'm not like, this is my guess. I don't know. That's why I'm here. But like, I would see that and think that that's a good sign, but I'm not sure.
Yeah, it's not so much the increase of the test scores, which is the problem. It's the disparity between the validation and the test scores.
Right, and I'm saying like your two lines are further apart in the earlier years, and they're much closer together in the later years. So you're getting much more accurate.
I guess so, but it just exhibits that, like, it's just another piece of evidence that the US and Australian Open are like separate, or at least perhaps aren't close enough to be used to predict like one for the other. So like for the Australian Open, right, even though they're both high, they're both like in lockstep pretty much, even in the early years. So that, I don't know why it's different for the US, but it just gives me, like, we have two red flags as to why we probably shouldn't be including the US Open. So that's why I decided not to include it. Yeah.
I was just wondering about the injury thing that the lady told. Why aren't we just considering it injuries? Because if we consider injuries as a variable, then what will happen is there are some players that might get injured frequently, or there might be some players that are not in game for a long period of time, which can affect the performance of the player in a particular tournament. So if that's the case, then we might be totally wrong in our predictions. If we are just considering, if we are not considering that factor, we might be just be totally wrong with our predictions. So should we not consider?
We probably should, or at least try it out, but I just never got around to doing it. Yes. We got like 10 minutes left. We better speed through this. Feature selection, three main techniques. So I talked about the test scores. So I ultimately use them. So like the average of the test scores from different years to tune my model and also to select features. Two other techniques as well. We have the XGBoost inbuilt feature importance, which is just counting how many times a variable is used to split a decision tree. So how many times which measures sort of how powerful, how valuable XGBoost found a particular variable. Then we have permutation importance as well, which is pretty cool. So for a particular variable, you strip out the data and then you shuffle it and then you put it back in and look at how how the model performance changes, right? So if the variable is actually really important to that particular model configuration, then if you put some noise in, for that variable, the model's performance is going to go down. If it stays the same, or if it even increases for whatever reason, then you have like a serious problem with that. So that's kind of another tool that you can sort of use. So that's kind of sort of included in the slides here. So the top table is the XGBoost feature importances. So these are like probabilities. They need to add up to 1, how many times a variable is used to split a decision tree. And these are the changes in the model's performance when you replace the variable with the data with noise for a particular variable, right? So this one, it seems that the model performance is basically staying the same, even if you've put in some noise. So it sort of suggests that this variable isn't particularly important. So that was a prototype model that I was working on, and this is my final model. So yeah, you can, I don't know, we're kind of running out of time, so I don't, yeah. So which features are important? Unsurprisingly, player rank, the logarithmic transformation of rank, and also ELO, the most powerful single features, but they basically convey the same information. So when you put all three of them in the model, they kind of fight it out. Two sink to the bottom, one rises to the top, and that's sort of like the order in which it goes. So ELO is, I suppose, a little bit more machine learning friendly than compared to log rank. Log rank is a bit more machine learning friendly than compared to rank. But yeah, that's pretty much it. Yes, so this is my final standings. So I've included two benchmark models. So one is an indicator function, the naive rank only. So it's just 1 if the player has high rank, 0 if they don't. And so in terms of accuracy, it does really well, which is kind of sad, but also, I don't know. The AUC score is obviously going to be like the same because there's no sensitivity to it. Log loss, I think I'm not sure if that's right. But it should
probably be infinity.
It should be infinity, right? Because if you're misclassifying a 1 as a 0, your log loss is going to blow up to infinity, right? I think the way that they calculate it, they just cap it at some finite number so it doesn't break your computer or whatever. And then second benchmark, slightly smarter, so a logistic regression with the rank differences. So obviously the log loss drops, AUC score increases a little bit, but unfortunately accuracy stays the same, which is really interesting. Yes?
It might be a silly question, but I'm wondering, if you just predict 0.5 for each game, do you get 0.5 loss?
For log loss?
Yeah.
Oh, I
think so. Because you have 0.5 probability times the log 0.5, which is 2.
What's log 0.5?
No, sorry. 0.5. No.
Can someone quickly calculate what's the natural logarithm of 0.5?
Is it natural log or?
Natural log.
Natural log. Oh, it's 0.3. I have Googled it.
Is it 0.3?
Yeah. Close to 0.3.
Okay.
Yeah, so you should get something like 0.3 if you predict 0.5 probability for each game.
Yeah.
I'm very confused. You get 0.5 something for log loss, and you say.
0.69.
Oh, okay.
Yeah,
okay.
Natural log of 0.5.
Okay, that makes sense then. Yeah. And then in terms of my final model, we have much better performance across all 3 metrics, increasing the accuracy by 4%, which is good. Log loss also drops as well to 0.5153. So if I compare this to my the leaderboard in the previous years, I'll probably be ranking about place 30, which is okay, I guess. Yeah. Let's see. Final thoughts. Let's not go into that. The big question. Can you make money on this? Which is, I suppose, half the reason why you guys are here. Obviously, I don't gamble. I actually, not really interested in gambling, but I love tennis. I love predictive modeling, so this is cool. Interesting benchmark. Bookmakers got 76.1% of predictions correct at the 2014 US Open. We're getting about comparable results, but it's different years and different tournaments, so maybe not that comparable. But it's based on data which is 2 months out of date. So I'm pretty sure if we had more up-to-date data, we could boost our rankings maybe by 1 to 2%, or maybe slightly more, do some more crazy machine learning, feature engineering, maybe 80% accuracy, don't know. Betting markets are also probably less efficient than stock markets as well, so some arbitrage opportunities to exploit there. Final lessons learned. Domain knowledge. I didn't really do any particularly crazy machine learning stuff, so I just know about tennis, so I felt that was driving most of my success. And in this particular application, feature engineering is much, much more important than compared to hyperparameter tuning. I don't think that's necessarily the case for all applications, but maybe you guys will know more about that than me. And having a robust validation strategy is also important. Cool, that's the end of my presentation, pretty much. Thanks to my data science mentor, Aidan Johnson, also Betfair's data scientists, who basically the tutorials serve as the cornerstone and foundation of my methodology and approach. Also, Jeff Sackman as well, who's the main source of this data. And he wrote some interesting articles on tennis analytics, so you can check out his blog, which I've linked on the final slide. Awesome. Thanks for listening.